Welcome to EMILAC Online tutorial. Before us is this dimensional analysis question, and it says the period t of oscillation of a simple pendulum depends on the length L and acceleration due to gravity G. Determine the exact form of the dependence. Now let us, from the first sentence, that t, which is the period, depends on the length and the acceleration due to gravity. Okay, now let us recall that the length of any parameter is given as, the unit is given as what? Meter, and the dimension also capital L. Then acceleration due to gravity, the unit is meter per second square, which is given as L t raised to the power of minus 2. Okay, now moving the term for proportionality, introduce a constant. So here you have L raised to the power of x and G raised to the power of what? Y. Now this x and y will help us to form the exact dependence between the length and the acceleration due to gravity and the time of oscillation. Okay, now let us now plug in the dimension of this. Now for the period, we know that period is given as which is time rather, which is in second, and which is also given as what? As time. Okay, now here we have that t now equals k. Then our length here, we have L raised to the power of what? X. And our G here is L t raised to the power minus 2 or raised to the power what? Y. Okay, now opening the bracket, here you have k L raised to the power x, then L raised to the power of y, because you multiply by the power outside. So here we have that t raised to the power minus 2y. And now the next thing is to reconcile the two sides of the equation. Okay, here you have t, then k, according to the law of indices, a raised to the power of m times a raised to the power of n, you have what? A raised to the power of what? M plus n. Now following this, using this rule, we apply here, you have that L raised to the power of x plus what? Y, then t raised to the power minus 2y. Okay, now for the left hand side, we see we don't have a L, so but we can introduce that. That will be what give us L raised to the power of 0, because we know that anything raised to the power of 0 is 1. So you have t, then equals to k, then L raised to the power of x plus y, then t raised to the power minus 2. Okay, now to this end, let us equate both the left hand side and the right hand side. So here we have L with the same parameters. We have x plus y, this is for equation 1, which will give us 0 equals x plus what? Y, equation 1. Then the next one is t equals t raised to the power minus 2y, which will give us, taking this is 1, you have 1 equals to minus 2y, equation 2. Now we can actually make y the sort of formula here. So our y here will give us negative 1 over 2. Now if we plug in negative 1 over 2 into the above equation here, take note that we can make y this x the sort of formula here, which will give us x equals what? Negative y. Okay, right. So to which we can say that x now equals to, our y here is negative half, so 1. Our x will now give us 1 over 2. Okay, right. Now let us now plug in the value of x and y into this. So here we have that t then equals to k, which is our constant, then our our x here is 1 over 2, then our g for y is minus 1 over 2, And let us take note that if you have x raised to the power 1 over 2, it implies the square root of what? X. And x raised to the power minus 1 over 2 implies 1 over the square root of x. Okay, if I were to apply this rule to this here now, we have that t equals what? K, then this is the square root of L, then times 1 over the square root of G. And took note, according to the law of the surd law, that A all over this, the square root of A all over the square root of B will give us the square root of what? A all over B. So T will now give us K, the square root of L over G. So this is the exact dependence of relationship between the period, the length, and the acceleration due to gravity. If you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.